SpaceX is developing a new satellite concept called Starmind, designed to move high-performance artificial intelligence computing into orbit. Instead of simply relaying internet traffic, these spacecraft would generate electrical power, run AI processors, and return computational results to Earth. The first concept, called AI-1, is essentially a compute payload surrounded by power generation and thermal control hardware. SpaceX says it removes much of Starlink's broadband communications equipment, including its large phased array antennas, while retaining optical links and spacecraft control systems. SpaceX's current AI-1 design target is approximately 150 kilowatts of peak electrical power, supporting roughly 120 kilowatts of sustained compute. The company's broader architecture targets about 100 kilowatts of compute per metric ton as the system evolves. But power is only half the problem. AI processors convert enormous amounts of electricity into waste heat. In a vacuum, there is no surrounding air to carry that heat away. The spacecraft therefore needs large surfaces that reject heat through thermal radiation. SpaceX compares the first AI-1 power envelope with roughly one NVIDIA GB300 NVL72 Class AI rack. Its initial reference designs could use NVIDIA processors, while later versions could accept newer accelerators as AI hardware continues to evolve. A single satellite would not operate alone. SpaceX proposes optical inter-satellite links, approaching the terabit per second class, allowing compute satellites to exchange data or connect with Starlink. Existing Starlink infrastructure could then provide part of the communications path back to Earth. The architecture depends heavily on Starship. These satellites require large solar arrays, radiators, and substantial quantities of computing hardware. SpaceX argues that a rapidly reusable, heavy-lift vehicle is necessary to move enough mass into orbit for orbital AI to scale economically. SpaceX says orbital AI compute satellites could begin deployment as early as 2028. It has also applied for authority covering a system of up to 1 million satellites. But that number is a regulatory application ceiling, not a deployed fleet. The real test comes first: power, cooling, networking, reliability, and launch economics.